Good afternoon, everyone. Let us start. Today, we shall take up a new chapter, that is chapter 3, graphical representation of data, about dispersion of measures of dispersion and correlation. We shall not practice on it because CBSE has deleted these topics for this session, and that is why we are taking up a new chapter, that is chapter 3, graphical representation of data. Now let me present my screen. Okay, this is the new chapter, graphical representation of data. Okay, so here one statement is here. Okay, one remark given by M.J. Moroni. He was a famous statistician. Okay, just I'm reproducing only few lines. It was very comprehensive. It was long, but I'm taking out only the important lines. So let us read. Just as a map gives us a bird's eye view of the wide stretch of a country, so diagrams help us visualize the whole meaning of a complex numerical complex at a single glance. Okay, just maps gives us a bird's eye view of a large part of a country. Okay, diagrams also help us to visualize the whole meaning of a numerical complex at a single glance. Okay, so with this, let us start. We have some rules for drawing diagrams. Okay, so these rules are given here. So we have to follow these rules while drawing diagrams. So the first one is title. Okay, title. So each diagram should have a suitable title. We should clearly convey the main theme. That means the title of the diagram should convey the main theme, okay, of the given data set. And you must know that for each diagram there must be a title, and generally title is given at the top of the diagram, though at times it is given at the bottom. So in the textbook you may find that title is given at the bottom, but in the practical work, okay, say for example this is paper, and here we have the diagram. Okay, and the title should be given here. Okay, title, we have to give the title here. Sometime in the book you may find that title is given at the bottom also, but generally we give title here. For example, say India. Okay, then soils, like this. So title generally we give at the top of the diagram, okay, in the practical work. And remember, the title should be should tell the theme, okay, the main theme of the data. Then next we have size. The size of a diagram should be such that all the important characteristics of the data are properly emphasized and can be understood by a look at the diagram. Okay, so sometimes with a little data you may prepare a big diagram, or with a lot of data you may prepare a small diagram. That should not be done. Okay, the size of the diagram must be proportionate. Okay, must be related with the size of the data. If there are a lot of data, then your diagram should be okay, in proportion with that, means it must be big. So that is the point mentioned here. And the size of the diagram should be such that all important characteristics of the data are properly emphasized. Okay. Next, we have this proportion and the length of length and the breadth. An appropriate proportion should be maintained between length and the breadth. Actually, we don't have exact rule for that, but one famous statistician, okay, called Lutz, in his book, uh, namely Graphical Presentation, has suggested that the ratio should be root 2 is to 1. Okay, that means 1.414 is to 1. So this is the product of root 2. Okay, actually, generally, here this is the diagram. Okay, this is the diagram. Here we have the white, and here we have the height, that is length and the breadth. Okay, height is here, the length, or here we have the breadth. So here this length should be proportionate with the breadth, or the width should be proportionate with the height. So actually the ratio given by Lutz is root 2 is to 1. Okay, see, but we don't have the exact rule for that, but generally here most of the time, okay, when we present the diagram, so most of the time, okay, the width is little greater than the height. In this way, this width or the length should be greater, okay, a little than the this height most of the time, and that is okay, uh, that is good. And desirable also. Okay, if the length is greater, or if the width is greater than the breadth or the height, that is desirable, and it also looks good. You must know that. Next, we have the scale. Scale of the presentation should be decided after taking into account the magnitude of the data. That is the range of the data. Okay, we have to find out the smallest value and the largest value. After that, you will know the magnitude, the range, and this scale of the presentation also depends on the size of the paper on which the diagram is to be drawn. So depending on the size of the paper, maybe the paper size may be small or big. Depending on that, your scale can be adjusted, and your scale also dependent on the magnitude of the data, on the range of the data. And the scale should, as far as possible, be given in the numbers, okay, in numbers or multiples of 5, 10, 20, 25, etc. Okay, and the scale should specify the size of the unit, then and the data it represents, for example, production of wheat in millions, and the lettering of the scale must be clear and legible. See here, when we prepare a graph, for example, so this is the diagram, and here when you give the scale here, it should be in the multiples of 5, like 5, 10, 15, or it can be in the multiples of 10 also, so it's 0, then 10, okay, 20, like this, or so on. Okay, and here you must give the this scale, then means a unit. Okay, you must write the unit properly. So if it is about wheat, then you must write production of wheat or production of rice. Okay, production of rice in a million tons, like this, MT. So you must write the unit properly. Okay, or production of iron ore in metric tons, like that. So you have to write properly, and here also you have to write properly. Then lettering of the scale also must be clear and legible. you must use, okay, most of the time capital letters, block letters for that. Okay. Then number 5, it should be attractive. The diagram should be attractive. A good diagram should be neat and clean. Okay, neat and clean. And diagrams that attract attention of the common man are said to be good. If a common man who doesn't know about the diagram attracts the diagram, that means your diagram is very, very good. Okay. Then a diagram should have footnotes and a source note. In order to clarify some points relating to the diagram, footnotes are given at the bottom of the diagram. Source notes are given to indicate the source from which the data have been obtained. So after drawing the diagram, okay, you must give, you can give footnotes, just telling about the description of the diagram. Okay, you can give a footnote, or you can write the source also. So for example, so we derive the data from census of India, for example, census of India 2001. In this way, we have to give the source as well as some important notes describing the this diagram. Okay, some points relating to the diagram must be given, just to clarify. Okay, then next we have index. Index explaining different types of line, colors, or sets should be given in the diagram so that its contents can be easily understood. Okay, what does this color represent? For example, here you have a diagram here. Okay, you have a diagram like this, and you are using this set for this column, and you are using this set for this column. So what does this horizontal line mean? And what does this inclined lines mean? So you have to write it, okay, here. So it may tell, say for example, male, so it may be female, like this. Okay, you have to give proper index, and for every pattern or for every color or set, you have to give its meaning so that everybody can understand it very easily. Okay. Next, we have simplicity. Too much information should not be loaded in a single diagram. Do not try to load all the data in a small diagram or in a single diagram. If the data are voluminous, if the data are large, then we can represent 2 or more diagrams, okay, depicting some identified characteristics. If the data is too big, then we can draw 2, 3 diagrams on different characteristics or on different sub-themes. Okay. Then we have selection of appropriate diagram. All types of diagrams are not suitable for all types of data. You cannot draw any type of data on, okay, for any type of this data. And inappropriate diagrams would give a distorted impression about a phenomenon under study. And if your diagram is not okay, suitable, if your diagram is not appropriate for the particular data, then it will give a wrong impression. Okay, then as such, extreme care should be exercised in the selection of a particular diagram to represent a set of figures. Say for example, so you have been asked to represent okay, land use data, to represent land use data. Then see, generally we find that to represent land use data, we use this pie diagram. Okay, pie diagram. And if you represent the land use data by this line graph, then it may give a wrong impression. So in this way, while selecting the appropriate diagram, you must be very, very careful. And likewise, see for the rainfall, okay, For the rainfall data, we use these bar diagrams. Okay, and for the temperature, we use line. So in this way, we have to choose the appropriate these diagrams. Okay, so these are the 9 important rules for drawing a diagram. Okay, so any question from your side? Any question from your side? Are you clear? Okay, if you are clear, then let me proceed. Okay, you are not responding. So next we have different types of diagrams. So the following are the important types of diagrams in common use. First, we have one-dimensional diagrams. Okay, sorry, dimensional diagrams. Number one, we have dimensional diagrams, and we have 3 types of dimensional diagram. The first one is one-dimensional diagram. They are in the shape of vertical or horizontal lines or bar. So this one, okay, this one is an example of this one-dimensional diagram. Okay, so they are in the shape of vertical or horizontal lines or bars. The length of the lines or bars are in proportion of different figures they represent. Means we use certain scales for this. We cannot draw as we want. Okay, we have certain scales here. We have certain scale. Then two-dimensional diagrams, they are in the shape of rectangles. Okay, they are in the shape of these rectangles or squares or circles. And these areas of these squares, rectangles, or circles are in proportion to the size of the item which they represent. Okay, so size of the circle or size of the rectangle, square or rectangle, okay, are proportionate. Then means for this diagram also, okay, it has a certain scale. And here we have the third type of dimensional diagram, that is three-dimensional diagrams. They are in the shape of cubes, blocks, or cylinders. Okay, 3D, three-dimensional. They are in the shape of cubes like this. Okay, they are in the shape of cubes or in the blocks. Okay, or this or in the form of these cylinders. Okay, or blocks, is like a cube. Okay, or in the form of blocks like this. So this is what I call three-dimensional diagrams, and here the volume of these cubes, then cylinders, and these blocks are in proportion to the given data, given values. Okay, size of the or the volume of these okay, diagram is related with the values. Next we have pictograms, another type of diagram. Here the figures are represented as pictures. Okay, are represented are pictures, and the size and the number of picture is in proportion to the given figures. So for example, 100 trees, okay, are planted. 100 trees are planted. So we have to represent it in the form of pictogram. If you select a scale, okay, if you have selected a scale that one tree, okay, is equal to 20 trees. Then how many trees we have to draw? How many trees we have to draw? That is 100 divided by 25, right? Okay, so we have to draw 5 trees like this. 1, 2, 3, 4, 5. Because one tree is equal to 20 trees. So to represent 100 trees, okay, which are planted, we have to draw these 5 trees. So in this way, the size or the number of pictures is in proportion to the given figure. Next, we have these cartograms. Here, maps are drawn, okay, and the figures representing phenomena at various spaces are shown by signs or symbols. So for the cartograms, on a base map, okay, on a base map, okay, let us continue. See, for the cartograms, here we have to represent these diagrams. Okay, we have to put the diagrams on a base map. For example, this is a map. Okay, so here we have the map, and here on this map, as given here. Okay, here maps are drawn and figures are representing the phenomena at various places are shown by signs or symbols. So on this map, say for example, population of Manipur, say proportionate circles. As for example, this is the population of Tamilong. Okay, depending on the size of the population, the size of the circle also may be different. So in this way, so we can put different signs or symbols on the map. So this is what we call a cartogram. Okay, carto cartogram. So here maps are drawn and the figures representing phenomena at various places are shown by signs or symbol. Next we have graphs and the curves. Okay, here the figures are shown in the shape of graphs or curves, and they can be either on natural or scale or ratio scale. Okay, for the graphs also, for the graphs and the curves, we have scales. Okay, that you will be knowing. And due to this time constraint, we will construct the most commonly drawn diagrams only. And for today, we have one activity. Okay, we have one activity. So before we start an activity, so any question from your side, boys and girls, do you have questions regarding the types of diagrams and regarding the rules for drawing the diagram? Do you have any question? Okay, then let us take up an activity. Okay, here uh, activity 1. Okay, construction of line graph. So for this we need a graph paper, or you can draw on the plain paper also. Okay, represent the following data with the help of suitable diagram. Here we have the data of this population growth. Okay, of population growth. Sorry, about the growth trends urbanization. Okay, about the trends urbanization means growth of urban population. Here, India trends urbanization from 1911 to 2011. So we need to select an appropriate diagram. So I think the most appropriate one will be a line graph. Okay, a line graph. the most appropriate one for showing trains is a line graph. And here we have the year, okay, 2011, 21, 31 up to 2011. And here we have the decennial growth, the growth in 10 years, okay, growth in the 10 years. And here for 2011, this is 31.16. So here this is the solution. And see here, okay, here uh, along the x-axis, okay, along the x-axis we are representing years, okay. So these are the different decades or years from 1911 to 2011. And here along the y-axis we have the decennial growth in percentage. So in this way we have to give proper okay, scale and this unit. Then here we have the title of the diagram. You should not forget to give the title of the diagram. Here the title of diagram is India Trains Urbanization, okay, from 1911 to 2011. And see here in this case, okay, see here in this case, one small square, okay, here one small square is equal to 1 unit. So see here in this case, one small square is equal to 1 unit. Just okay, let us see here. This is 0 and 5 is here. See 1, 2, 3, 4, 5. Okay, 1, 2, 3, 4, 5. That means one small square is equal to 1 unit. Okay, 1, 2, 3, 4, 5. So the first value is 0.35. That means less than 1. Okay, here we have 1911, then we have 1921, and for the 1911 the value is 0.35. That is, it is less than 1. So this is 1, okay, to the 0.1, 0.23, okay, 1, 2, 3, 4, 5, 0.1, 2, 3, 4, 5, or 1, 2, 3, 4, 5, okay, 1 unit. And see here, it is less than 1 unit. That means it is somewhere here. 1 is here, somewhere here. This is 0.35. And likewise, see here we have 8.27 for 1921. We have 8.27. So if 5 is here, then 6, 7, 8. Okay, just 1, 5, 6, 7, 8. 8 is here. Okay, 8, then 0.27, a little above this 8. Here we have 8.27. So in this way we have 19.12 here. Okay, 19.12. 20 is here, and see 19 is here. Okay, 19 is here because 15, then 16, 17, 18, and 19. Then 1, 2, that is a little above this 19, and so on. Okay, likewise we have this 31.97, that is 32, for example, after rounding. Okay, 30 is here, then 31, then 32. Then here we have 41. Okay, 40 is here, 40, then 41.42 for the year 1951. Likewise, for the year 1961, we have 26.41. 25 is here, okay, 26. Then 0.4, that is little above 26. Likewise, we have 38, okay, here 38.3, 35, 36, 37, 38. And here we have 46.14, okay, here this is 45. Then 46 is here, okay, little above 46. Likewise, we have 36.47, and here we have 31. Okay, 30 is here. This is 31.13. and here this is 31.16, almost the same. So in this way we have to prepare, okay, we have to prepare the graph. Any question from your side? This graph you can draw on the plan paper also. Did you collect graph book from the store, boys and girls? Nobody is responding.
Yes, sir.
Okay, if you don't collect, then you can draw on the plan paper also. Okay, plan paper I mean one side of your notebook is a line, on the other side it is blank. Okay, on the blank side, you can draw it after making the proper scale, or you can buy graph paper from the okay market. Okay, any
Yes,
question?
sir.
Any question from your side? If you don't have questions, then let us stop here for today. Okay, and thank you very much for joining my class. And don't forget to send your
Thank you,
names in the
sir.
WhatsApp group.